Yeah, it's good. You can come to our little party for it. Oh, like yesterday or 2 nights ago. I probably sent you a Facebook invite. No, we planned it like 18 hours before it happened. So. Oh, okay. So just during Tender, so. Yeah, it was on Sunday night. Yeah. Mm-hmm. Yeah.
Who else gave her recommendations?
Dominic Williams was one.
Oh, really?
Yeah. I think she got Zuko as well. Yeah. Yeah. She had to do like a second attempt. Like so the first try they came back with a request for more information. So that's why she had otherwise like she was trying to get it done by January, but now she started paying because now she had to start paying tuition, which sucks. Yeah, she can pay some, but it's like you pay progressively more. Whoa, lots of light. Hey. Sure. Yeah. Yeah. Mm-hmm.
It's running, so.
Sweet. Cool. Oh, the live stream is running? Hi, Internet. Hello, Internet. Mm. Shit, should I go to the bathroom? Where's the bathroom?
Down that one. Hi, nice to meet you. How are you?
Good.
Hey. Thank you. This is the first mystery. Have you met Gloria, by the way?
No.
Oh, shit. Okay, this is Christine.
Hi, Gloria. Nice to meet you.
Oh, okay. What's the time? Play time yet?
Yeah, it's like 6
Okay. I probably like about an hour and a half. Hour and a half, sorry. Yeah. You can flip out whenever.
Okay. All right, cool.
I think it's been live streamed. So
Live stream? Oh, live stream? Oh, live stream.
yeah,
Are you all set up?
yeah, I think so. Yeah, let's go ahead and start. You can go ahead and make opening announcement, yes, if you want.
Hello everyone, we're going to start the meetup soon. Hope everyone's excited to get some technical knowledge from Sunny, our core developer. I'm Django and Jane of Cosmos. Nice to meet you all. And I have some announcements just so everybody knows. All of these workshops sort of lead us into 2 hackathons we have, prepared this year, and leads us to the end of the year, which we're going to be launching a investor/app developer meetup, where we're going to have developers who have prototyped something using the Cosmos SDK and are intending to hook up their DApp chains to the Cosmos Hub using IBC to match them up with real investors, VCs, and for you guys to potentially prototype your proof of concept into MVP and onto a mainnet. So just so everyone knows, these workshops will lead into something tangible if any of you guys are serious about building on the Cosmos SDK. So that being said, Sunny.
Thank you. Hey guys, my name is Sunny. For those who don't know me, I'm a researcher at Cosmos, Tendermint. I was also one of the co-founders of Blockchain at Berkeley about three or 4 years ago now. And yeah, so I was told that I have 3 hours to do a presentation. I'm probably not going to take the entire time, but the thing is, like, normally, like, people give me at conferences, people give me like half an hour or 45 minutes, and like Cosmos is a really complex project, and like I always had like trouble like fitting it in and like making it fit in that 30-minute window. And so I'm like, all right, now I have like all the time in the world to like give the presentation I've always wanted to give. And so bit of context, the slides are going to look a little bit weird. Like it's just like switch formats randomly, because really what I'm doing is I took like a lot of slides from like past presentations of mine. I'm like mixing and matching them in order to like create this like longer form presentation. So without further ado, let's go ahead and get started and talk a little bit about what is Cosmos. So the tagline I gave this talk was many chains, many tokens, one ecosystem, and hopefully I'll explain what that means. So before we start talking about blockchains, let's just talk a little bit about like the evolution of like human coordination. So I assert that the first stage was we had these like ideas of villages and kingdoms where they were relatively isolated. You don't have much like economic integration. You basically only really trade with your like neighbors, and that's about it. And because of that, like they just weren't able to scale very high. And so I assert that like historically what we see is that economic growth comes from increased economic connectivity. So as you're able to trade with more people, you get more and more growth. And so I think the second stage of civilization was empires, where basically we realized that, okay, how do we get people in Greece to trade with people in Persia, right? It's like how we do it is by having like everything under a common set of laws and rules, where every common ruler. So you have standards. You have if they don't want to trade, well you put a gun you march your army on them and force them to trade with you. And so this is kind of like what we did. And I'm sure I don't have to explain to you guys like what the downfalls of empires are, like the moral hazards and whatnot. And so I claim that the greatest innovation of like humanity in the last 100 years is that we realized how to do okay. So the third step was what we have today, which is nation states and city states. We kind of have a combination of them in the world, like nation states, countries like Germany, France. We have city states, countries like Singapore, Monaco, etc. I actually think we're seeing a shift towards more and more city-states. We see this in, like, for example, Catalonia trying to secede away from Spain, which I consider that sort of a city-state. And so essentially, I think what the greatest innovation of humanity in the last 100 years was we realized how we can do economic integration without political integration. And so, we did this through a multitude of technologies, including, like, free trade zones where, we came to coordination saying, like, okay, in these areas, free trade is, like, the norm. We had containerization. We came to standards upon how to, like, package goods and ship them. So, everyone's following these same standards. We didn't need, like, a government telling us to do it. Rather, we did it through, like, sort of like voluntary organizations. And so institutions helped as well. Things like the UN. It's not quite a government, but it's like, a common forum where people can come to and like discuss, like, problems and whatnot, and, like, hopefully try to resolve them. As well as, the internet. I think, internet has helped obviously a lot. Now it's it reduced transaction costs for doing business with anyone from anywhere over the globe. And, I think hopefully blockchain will help push this as well, economic integration without political. But so yeah, these are sort of the technologies that helped create this, like, more decentralized political environment that we see today, with high amounts of economic integration but low amounts of political integration, which is, I don't know, in my opinion, this is political. Obviously, it's going to be a political statement, but I'm somewhat of a localist, and I believe that, like, coordination works at smaller numbers when people have more similarities, and, like, the whole Dunbar's number and all that. So, I think you can get better coordination through smaller political entities while still having the larger economic systems. So let's compare this to the evolution of blockchain development. Step one, generation one, came a bunch of independent blockchains. You had the Bitcoin. Bitcoin was the first blockchain. And then after that, you had many other blockchains that started coming along, each trying to do, like, slightly different applications. Some of them were not doing different applications at all, right? Like Litecoin and stuff. They were just trying to, like, play with the monetary policy a little bit. But then you also had some things like, Namecoin trying to create, like, a decentralized DNS system. You had Saya, who was trying to create, like, a decentralized storage marketplace. And so you had all of these different blockchains, but, like, they weren't really able to communicate with each other or anything. They were kind of all in their own isolated environments. There are also other issues with it. Back then, like, Bitcoin was the Bitcoin code base was the only blockchain code base that existed. And so if you wanted to make your own application, really what people used to do was, like, fork the Bitcoin code base and try to modify it. But, like, Namecoin did this, for example, and it's just clearly a suboptimal solution. It's very poorly designed because fork of the Bitcoin code base. And the Bitcoin code base is, like, wasn't designed for that. It's just designed to do payments and nothing else. So, so we'll get into that a bit. But then along came generation two, the empires. These Ethereum basically created what I consider the first empire, which basically said, okay, here is, like, one monolithic stack, and, build your applications on top of me, and, I will provide you great amounts of economic connectivity, and, you can have, like, the 0x project. I can use my maker DAI to trade, to gain leverage on, like, and then I can, like, use that in a 0x or something. So you get high amounts of economic integration, this whole, like, DeFi movement that's been going on in Ethereum. But you also get a lot of cons. You have, like, very little, any individual application has very little control over governance. You kind of, like, if you, let's say your system has some issue with it and you need governance to solve it, you somehow need to convince the entire Ethereum community to bail you out rather than just, like, your own personal community. So you lose out on some, your community loses out on some level of sovereignty. You also have to, to use Ethereum, you have to pay your fees in Ether. This is essentially a tax. It's, like, no different than the tax that empires charge on, like, their constituents, right? And so essentially, the more people they have using Ethereum, it boosts the price of the Ether token. When, maybe if you had your own blockchain, you don't want to do that. You can use your own your own token to pay fees. So I propose that the solution is this: generation three, where we have, many application-specific blockchains that are all interoperating with each other. So, this is a Cosmos hub chain. This is Namecoin, Sia, Augur, Bitcoin, Ethereum. I still think smart contracting systems will stick around, and I think they're useful. But I'll get into a bit later of where they're useful. But we're not going to have Turing complete VMs here. We're not the Augur contract is not going to be a smart contract written on the EVM. It's going to be like something that's written into the core code base of that blockchain. So kind of like how Bitcoin, its code base isn't written on the EVM or some VM. It's just in the client code base. And this has a lot of efficiencies and whatnot, which we'll get into. And so that's what I imagine that most of these blockchains will end up looking like. You'll still have some of those Turing complete VMs, and we need a way for them to interact with each other. We need these links between them where they can send data between each other, send tokens, send assets, like build a common economic connection. And so that's nice. That sounds good from but I don't want to make just an appeal to analogy here, right? I think that this generation 1, 2, 3 of the blockchain ecosystem clearly maps very well to the of human coordination, but that's not a strong argument. So let's talk about why. So what I'll do for this presentation is explain why we want this kind of design, what tools my company Tendermint is creating to build this, and so we'll start by talking a little bit, but why do we want a generation 3? What was wrong with generation 1, and what was wrong with generation 2? So generation 1, the benefits here are the sovereignty aspect. The Sia community has control over the Sia blockchain. When they realized that people were there were ASIC manufacturers who were about to gain a controlling share of the Sia blockchain network, they hard forked their hashing algorithm, right? This is something that they could only do because it was a small, close-knit community. You have way more efficient state machines. I claim that the Bitcoin state machine is way more efficient than the Ethereum, the EVM, because it's it's just simpler. It's adapts. You're running compiled code, not interpreted, and you get a high amount of customizability, right? The other thing with Ethereum is in the Empire model is they force things upon you. So for example, you can't choose what cryptography you want to use because Ethereum only has certain precompiles that they chose what precompiles to use, and you can't say, oh, I don't want to use SHA-3. I would rather use a different hashing algorithm. You can't do that, and so you lose out on a lot of customizability when you're living in someone else's empire. And so that's what these are the benefits that generation 1 gave us. Generation 2, on the other hand, gave us all that interoperability I've been talking about. It made it easier to develop. So like I said, if anyone's tried playing with the Bitcoin code, it's this spaghetti code, C++, monolithic, very messy. It's very hard to understand. And it's because of that, it's very hard for people to fork it and make complex applications with it. So Ethereum, made it way simpler. Solidity is not fun to write, but it's way better than trying to modify the Bitcoin code base. And Solidity is not, it's getting better and better over time. So generation 2, it made it way easier to develop. And there was this whole one-click deploy thing where I write my code as a developer, but I just press a button and it deploys it and it's live. I don't have to go out and find miners to mine my chain and whatnot. So yeah, so the goal here would be we want this generation 3 to somehow combine the attributes of both generation 1 and 2. Can we get the best of both worlds here? And that's cool, but let's go even further. How much can we do even better than just that? What are some, if we're going ahead and building another generation, what else can we add to this system? So, when looking at designing distributed systems, one of the best places to always look for inspiration is the largest distributed system in the world, which is the internet. And, the internet, its goal was to connect multiple separate networks of servers into a single network of networks. That's kind of what I'm proposing our solution is, Cosmos, the internet of blockchains. The ability to scale in terms of throughput and geography, and the ability to tolerate and recover from failures. Well, if we look at our goals for the internet of blockchains, it's actually pretty similar, right? We wanted to be able to scale a number of users and throughput and geography. We wanted to tolerate and recover from failures. And so, let's go ahead and add those two to our list of desires that we want: scalability and fault tolerance. And then I'm going to add a third one that I personally, care a lot about, which is this is the energy consumption of proof of work over the last year. Luckily, it's gone down a little bit because the price of Bitcoin has gone down. But at its peak, it was doing 75 terawatt hours per year. Everyone always gives the analogy of, oh, that's as much as this country. I don't know what it's actually similar to, but I heard something like Denmark or something was at the peak was what it was using as much electricity as. Yeah, this isn't cool. I don't want, I want to care. I want to let's also worry about making this sustainable. These are the 9 goals that we have in the generation 3 of blockchains. So, and there's a 10th goal that Cosmos, we kind of isn't our focus, which is privacy. And so the whole generation 1, 2, 3 is always a little bit misleading because, where does Zcash fall on that? It's not a linear timeline. It's really like a tree of development, or even like a DAG, things are borrowing stuff from each other. But, privacy is a very important 10th thing that we need to work on. But quite honestly, the Cosmos team, that's not our specialty. And so we don't really focus on that ourselves. Instead, we just give a lot of money to people who do that. So, we fund Dan Bonnet's lab at Stanford, as well as Alessandro Chiesa's zero knowledge proof research here at Berkeley. So that's not our focus, but that's definitely something.
What's the difference between the Dan Bonnet and also the Berkeley research, in your opinion?
Well, so Dan Bonnet, so Chiesa, he's basically focused completely on zero knowledge proofs. That's his focus. He was one of the co-authors of the ZK Snarks paper. He's one of the co-founders of Starkware, and he's currently working on a new construction of zero knowledge proofs called Aurora. So Dan, on the other hand, he's more I don't think he actually does much in zero knowledge field at all. He's just focused more on BLS signatures. He's been doing a lot of work on aggregators lately. So he's more I'd consider traditional cryptography and making things more efficient, while Chiesa is more on the zero knowledge proof side of things. And so on the privacy side, so one of Dan Bonnet's grad students, Benedict, he helped create bulletproofs, which is also a zero knowledge construction. So they do dabble in it a little bit as well. Yeah. Also, sorry, I should have mentioned this earlier. Feel free to butt in with any questions at any point. Yeah, thank you for that. So yeah, back to this. 9 goals. All right. So here's what we want to create. How are we going to do this? These are the tools that Tendermint. By the way, it's going to be a bit confusing because Tendermint is the name of our company, but it's also the name of a bunch of our tools, and so it will be a little bit confusing. But gotta bear with it. So these are the 11 tools that we're building, and that are going to achieve the goals that we want for this generation 3 blockchain ecosystem. From here on out, I'm just going to call this generation 3 thing Cosmos. So Cosmos is not the name of a single blockchain. It's not the name of Cosmos is just the name of this vision of how do we create a generation 3 ecosystem of application specific chains that are all talking to each other somehow. So these are the tools that we're going to use. Tendermint, Cosmos SDK, and IBC are kind of what we call our 3 flagships. And then, some of the, peripheral stuff that go along with, helping us achieve those 9 goals that we want. Yeah.
Are any of those 100% production ready?
Yeah, so the one that's the most production ready is Tendermint Core, which is the next thing I'll be going into. But it's, it's been around. I'll just actually go into it. I'll jump into it. So we'll start off with Tendermint because that's the first thing that we created. Tendermint was created by Jay Kwan back in 2014. He was just he got into, he wanted to make an exchange and he was worried about the finality properties of proof of work. So he started reading into BFT research and, he read PBFT and he was like, oh, I think I can make this better. So he created a consensus protocol called Tendermint. And so Tendermint that's also why it's the name of the company. So they spent, Jay and Ethan Buckman, who's the CTO, they spent about 2 or 3 years in what can we do with this now? And then that's kind of when we started thinking of okay, this is the whole Cosmos vision that we're building. So Tendermint, It'll be a little. So Tendermint is also, like I said, it's an overloaded term. It's the company, but it also refers to the consensus protocol, like this abstract notion of the protocol, and that which I'll call Tendermint BFT, and then this Tendermint core, which is our actual implementation in it's a software implementation. So with Tendermint BFT, it's basically this two-round commit system. I don't want to go too much into the technicals of Tendermint. In each of these sections, I'll have like a list of further reading you can do if you want to learn more about any of these topics. So essentially, this is a great, obviously you can't read it right now, but this is a great one poster. We need to print it out and have it in our office. I don't know why we don't yet, but this is like probably the best quick explanation of Tendermint BFT that I've seen. I'll have a link to it. So yeah, what is Tendermint BFT? It's a simplified and improved BFT. So what this means is, I can give a brief summary. What happens in PBFT is you have a BFT consensus protocol that's going, and you have one leader who is proposing values and everyone else is committing. And it works very well in this situation. But the leader stays the same. If the leader goes down, PBFT switches to a different mechanism for leader re-election. And this leader re-election mechanism is, very complex and whatnot. And so, a lot of thought has gone into improving the leader re-election. So if you guys know Thunder, they have a mechanism where they fall back to a proof of work blockchain to do the leader re-election. I think that's actually very silly. What Tendermint does instead is basically what Jay's innovation here was he figured out how to do it all in one round or in one mechanism. So you can do the leader re-election at the same time as you're doing consensus on values. And so what this does is, it allows you to not have this. It simplifies the protocol significantly, and it also allows you to change the leader every single block. So, you can imagine that PBFT is not good for a public blockchain because that you're designating one person as the proposer every single time, and that's a huge censorship concern, right? But with Tendermint, you can change the proposer every single block, and this, allows, it's a censorship resistance mechanism because now you don't have one proposer who can choose what transactions go in or not. If one proposer is censoring you, it's fine. Hopefully the next proposer will not be. And it also was very well designed for, working over a gossip network, where the problem in PBFT is when there's Byzantine faults, like malicious faults, to show evidence of it, there's a lot of back and forth required. So if we you faulted and I wanted to share information from you, there's a lot of back and forth communication, and it kind of assumes that the two people have a direct connection to each other. Tendermint, the evidence is very compact, and that makes it very efficient for propagating over a gossip network, which is what blockchain networks usually are. And so it's also very well designed for use in public gossip networks over the public internet, while PBFT was only really ever tested in private permission settings. So Tendermint, we are heavily consistency prioritizing or safety favoring. So Tendermint, what it will do is if there is it is safe in asynchrony. So what that means is, let's say half the nodes cannot talk to the other. The transatlantic cable was cut or something, right? The entire blockchain will halt. No more blocks will come until we figure out how to resolve the situation. A liveness favoring blockchain, on the other hand, such as any proof of work chain, it will instead go split brain, creating two forks that will not be able to resolve. And so, I think the safety favoring, it's very important from, to me, blockchains and consensus protocol were about coming to consensus. Why would you want something that is inferior to coming to consensus? I think safety favoring systems are superior to liveness, but and so, we have provable liveness and partial synchrony. So unlike Bitcoin, where if the synchrony time accidentally goes, so let's take Ethereum, right? It has block times of 15 seconds. If the network delay exceeds 15 seconds, the blockchain will never be able to resolve. It'll just remain in a perpetual fork where it will never come to consensus. In Tendermint, as it doesn't matter how long the delay is, as long as it resolves at some point, it will continue to make progress. So if let's say the block time suddenly, the proper network propagation time suddenly jumps to like 30 seconds. It's fine. The system still works. It'll just be making blocks every 30 seconds instead of 1 second. Yeah, I talked about the rotating proposer. It has a safety threshold of 1/3 of the validator power. So as long as less than 1/3 of the validators are not malicious, it will never fork. And as long as less than 2/3 of the validators are not malicious, we will always be able to attribute who was malicious and be able to punish them somehow. And then finally, we have like Tendermint 2.0 in progress. That's how we can make it even more scalable. Things like VLS aggregation for signatures, pipelining. So these are all like, if you're interested in that kind of stuff, you can come talk to me afterwards. And so why does Tendermint BFT help from a scalability perspective? It comes down to that idea of safety and asynchrony, and rather liveness and partial synchrony. The problem with Nakamoto consensus is if your propagation and mining time exceeds your block time, the system will go split brain, like I talked about. Like you'll have two forks that will never be able to resolve. On Tendermint, however, so that's what happened here. What happened here is the block. This is like step one. The time increased. Now the system went split brain. In Tendermint, on the other hand, let's say the propagation time went increased suddenly. It's okay. The liveness and partial synchrony aspect of Tendermint will just increase the block time and make it safe. And so what this allows is it allows you to push the block time as low as possible. So in Bitcoin, the reason the block time is so high is in 10 minutes is because they're very paranoid that they don't want to ever get into this situation. So they think 10 minutes is a long enough time. Same thing with Ethereum. You can't really push it lower than 15 seconds. And already that 15 seconds, I think, is a little bit too low. We're having too many orphan blocks right now. That's why in Tendermint, you can push the block time, have the default be 1 second, and it's fine. Because if it doesn't work in 1 second, it'll just happen whenever it needs to. And so, you can have way more blocks happening, way more transactions happening. The safety property of Tendermint allows you to push the system to its limits, which you cannot do in Nakamoto consensus. So, yes.
How real of a concern is that? Like, will that ever happen in Bitcoin?
Not in Bitcoin, because 10 minutes is insanely high. But in Ethereum, I could totally see it happen. 15 seconds and, sudden internet network delays, like pushing it beyond 15 seconds I think is a very reasonable system, especially when you're starting to run over, let's say you're trying to run your blockchain over Tor or something, right? Where the network delays are very high and unpredictable. Yeah. So, Tendermint, all right, it helps us with two of these concerns we were caring about, which is the scalability, like I talked about, and the fault tolerance. And if you want to learn more about Tendermint, we have a formal specification written by Zarko, Jay, and Ethan. A lot of people didn't like Tendermint for a while, a lot of academics, because Tendermint has a very engineering focus rather than academia, and so we just we wrote a small spec and just started implementing it without doing the form. We had heuristical proofs, and so that's why a lot of people academics were it's not real until you have a proper paper. So finally this year, last year October or so, we finally put out a proper paper with formal proofs of safety and liveness, and so you can go ahead and read that. That link, that cool poster thing, that's that link. And Christine wrote a blog post a few months ago comparing Casper to Tendermint. And so, one of the main things is Casper still seems to be liveness favoring for what reason I cannot imagine. So, Tendermint core. This is our actual implementation of Tendermint. So it's written in Go. There is some very early progress in rewriting it in Rust right now. But it is the first production grade BFT consensus engine. A lot of people thought that BFT doesn't scale because almost all of the implementations were written by grad students for their thesis or something. And so, they wrote it in Python, single threaded, that's not how you build a production system. If you want to build a production system, you need to have concurrency, multi-threaded systems. And you also have to writing a Tendermint looks so simple in this nice little diagram, But when you actually start getting to like writing an implementation, it's like, you have to start worrying about like, you think you're on round 3, but you're suddenly getting blocks from round 5, and you're like, what's going on? Are these malicious blocks, or are these like, am I just delayed from the rest of the network and everyone else is on round 5? I'm on round 3. You have a lot of caching, and like, building the production implementation is much more complicated than just like a small prototype. Yeah.
What is Rust gonna give you that Go doesn't?
Just slightly better performance. I'm not a Rust developer, so everyone else seems to be going crazy over it. So Buckman, who's the CTO, he's the one who's really been pushing the rewrite in Rust. So I think he's just working on it on his own right now as a little side project. But I think it's just a performance benefits. Yeah. And so yeah, Tendermint Core, first production grade BFT consensus engine. I think the second production grade BFT is the Honey Badger implementation by the POA network team. So I have an eye on their implementation. It's pretty cool. And so what Tendermint does is it handles all the P2P and consensus logic for you. We'll get into it in a second. And here's another view of like how Tendermint works. Yeah, so scalability. This benchmark was from like 3 or 4 years ago, so this is very clearly outdated. And this 14,000 number sounds high, but it's very misleading, because this is Tendermint running without a state machine. We're just coming to consensus on bytes, but not actually processing those bytes in any way. So in a blockchain, really, you're like, lot of the limit is actually in the state machine, not in the consensus protocol. So as soon as you slap an EVM on top of Tendermint, it quickly jumps from 14,000 to 200 transactions per second. But that's still way better than Ethereum proof of work's 15 transactions per second. So there is you do get some scalability benefit. It's not as it's not the magic bullet, because really what you have in scalability is there's 2 types of scalability. There's what's called vertical scalability and horizontal scalability. Vertical scalability is how much you can scale a singular blockchain. So like scaling, it's kind of like scaling, getting a beefier and beefier server. While horizontal scalability is you have you scale out, like you buy more servers that are, or you use some sort of parallelism. That's what like horizontal scalability is. And so Tendermint Core gives you a decent amount of vertical scalability, but it's not the magic bullet, which is why we need the rest of Cosmos for the horizontal scalability. But oops. So the other thing, what Tendermint does is a blockchain essentially has 3 layers to it. There's a networking layer, which handles peer-to-peer, gossip, etc., transaction propagation. There's a consensus layer, which does like the actual BFT consensus engine, and then there's an application layer, or a consensus layer could be like the proof of work, and then there's the application layer, which is the state machine of a blockchain. So in Bitcoin, it's their UTXO processing system. In Ethereum, it's the EVM is the application layer. What Tendermint does is it creates a standard software stack that handles these bottom 2 layers for you, and then you can write your application layer in any language you want, and it talks over a socket protocol called ABCI. And so it's similar to like you would have like different services running that talk to like an Apache web server. Same thing goes here. You have your state machine written in any language you want, talking to Tendermint Core. And so you can take the EVM, run it on this called Aetherium. Someone took the chain.com VM and ran it on Tendermint. They called it Chainmint. And we have implementations of we have example applications for running on Tendermint Core in like every language from like Practical to OCaml. And another cool thing what Tendermint does is it allows you to define your own validator set however you want. So you can use Tendermint in a proof of authority setting, in a permission setting, or you could use it in a public proof of stake setting. You could even use it in a proof of work setting if you wanted to. Not in Nakamoto consensus proof of work, but rather people are doing hashing, submitting hashes to the chain, getting voting power, and then are able to use that voting power to become validators in the system. I haven't seen anyone implement this yet, but I'll probably go ahead and do it at some point if I don't see anyone else doing it for a little while. I want to show a proof of work BFT system. So that'd be really cool. And one of the benefits of this, like being able to define your own validator set, which is what Tendermint Core allows you to do, is it enables what like a level of sovereignty. And so, if anyone knows what this flag is, it's the flag of a country called Liberland. It's like this little made-up country in between Serbia and Croatia, caused by an interesting, weird geographic quirk. And so, I've been helping their team out. Just for me, it's just a little sandbox for different blockchain like proof of concepts. So like, if I want to create like a voting system or something, I'd go test it in Liberland and then like go to a real country and be like, hey, look at my little sandbox. It worked there. You want to like try it in like Zug or something. So that's why I've been helping them out with that project a little bit. And so one of the things is that like, I believe that you can have higher security than pure economic incentives alone. This kind of goes back to my whole belief in like localism, where if you have like some level of community incentives beyond just pure economic, you can achieve higher like coordination and security. So if like all the validators of Liberland were Liberland citizens, right? Like, and that was part of the mechanism of like becoming a validator, that could, they have social and political incentives beyond just pure economic, and they're less likely to try to attack the system than if they were just doing it out of a pure profit motive. And so there is this like, it could still be proof of stake, but with other requirements, right? So having to have the Liberland asset citizenship, it's like an asset, and so it's like marked on your UPort ID. So that could be a requirement. So I think there's this like interesting continuum between private and public blockchains. It's not just this like binary thing. And so there's a lot of room to explore there. And I do think sovereignty can help you with security. So, right, Tendermint Core, these are some of the benefits I gave. We got that sovereignty I just talked about. You have the customizability. You can write your state machine in any language you want. You can write any state machine you want. You can take an existing state machine and run it on top of Tendermint, like we saw with like the EVM or the chain.com VM. It helps with the scalability, like the vertical scalability we talked about, and it helps with that one-click deploy system where like, you no longer have to go out, you still have to go out and find your validator set, but it helps in the situation where like you don't have to write a consensus protocol or peer-to-peer logic. Like most developers, they want to write their application logic and not go and write a consensus and peer-to-peer by themselves. And so it's nice that Tendermint just wraps this up and handles it for you. And so if you want to learn more about Tendermint Core, there's the documentation. There's some performance testing results that are way more recent. So that graph I did was like 3 or 4 years ago. These results, ChainDB just did some performance testing about 3 or 4 months ago. And so they have way more up-to-date performance numbers. And then Ethan Min's master's thesis, which kind of it's also a good resource for just Tender BFT as well as some of the design of Tendermint Core. All right. So, like I said, oh yes.
So about BigChain, they announced that they were going to integrate Tendermint last year, and they said that as soon as it's stable, what's kind of the delay in
I'm not sure what the status of BigChainDB is as a project. From what I understand, last thing I heard was, they gave that team created a BigChainDB Foundation, gave that project to BigChainDB, and now they're focusing full time on Ocean Protocol. And I'm not sure who's actually developing BigChainDB right now. I'm not too up to date with the actual internals of their project right now. Sorry. And by the way, a number of people are using Tendermint Core already who maybe aren't using any of the rest of our stack, not using our Cosmos SDK or anything. So like, we have like a FX exchange that does over $1 billion per day. They're using Tendermint Core internally. The national Thailand is using Tendermint right now for their national ID program. I heard rumors that PBOC, the People's Bank of China, is using Tendermint Core right now. So yeah, there's a number of people who are using Tendermint already and in production systems. Yeah, and so any other questions about Tendermint BFT or Tendermint Core? Yeah.
So, you know, if you go to GitHub, it says alpha,
Mhm.
don't use, and every time, and it's been in the past that every time there's an update, you know, the file format changes and
Yeah.
it's not backwards compatible. Is that still the case? You know, pretty much any update will make you restart your.
Yeah, right now, basically right now, even Tendermint is going under wrap, and like we're not playing too much with that. What we're playing with more is like, you know, a lot of the stuff around like ABCI and stuff, like some of this, you know, adding fields to that protocol, that socket spec and whatnot. So yes, right now, Tendermint core is pretty solid from a BFT standpoint, but just from the like tooling around it, it's still going under rapid iteration. And so if you are using Tendermint core, we do highly right now until it reaches some level of stability. We do recommend like having some sort of direct lines of communication with us. Like we'd love to add you to like our partner Slack or whatnot to coordinate there.
Yeah, like, you know, one of my experience last year,
Mhm,
like
mhm.
you got one version and you upgrade to another version, and all of a sudden there's new requirements and you can config files. So
Yeah, yeah,
So I don't know. I'm kind of hoping for a time where it's like stable and you can say, okay, it's
yeah.
this version and the next version is gonna not require you to change your
Right.
infrastructure.
Right. We're going to like start shifting into more like, you know, better versioning, where like, you know, we'll continue to support older versions and, you know, obviously upgrade them with bug fixes and stuff. Right now, we've kind of been only having one development pipeline where bug fixes are going in the same spot as features and whatnot. And so we do definitely have to improve on that process and make it easier for our end users, which is you guys. Yeah. Right. Okay. So like I said, you can use Tendermint core with any mechanism of choosing your validator set, and that's decided by your state machine. Your state machine basically tells Tendermint core, here is the validator set. And you can use it with permission system, but what we personally propose is using it with what we call bonded proof of stake. And you know, why proof of stake? You know, this is like a tweet thing I did from like 2 years ago now, 2017. But like, you know, there's a lot of benefits, which is like, you know, the environmental, the scalability, which is actually not correct because, you know, proof of stake itself isn't what's giving you scalability. It's the BFT, Tendermint BFT, that's giving you scalability. But people often like, you know, same thing with proof of work. People often mix up Nakamoto consensus, the consensus protocol, with the Sybil resistance mechanism, and they're really pretty distinct. Same thing with here. So scalability, not really, but you know, it could possibly help with decentralization, where like, you know, ASICs continuously just keep getting more and more centralized. It helps you with like dishonest resistance. And so, you know, some basics like, you know, you use bonded tokens as the resource limiter for determining voting power. So, you know, you take some of your tokens, and one of the chains that we're building called the Cosmos Hub, the token is called an atom. So you go ahead and take your atoms and you like put it in a bond, and whatever percentage of the bonds you have were yours, that's how much voting power you get. And you know, it eliminates the wasteful energy consumption of proof of work. Instead of using energy as the resource limiter, you use locked capital. You build, and you know, in my opinion, Dan Robinson made this click for me, where like, you know, in proof of work, when you burn electricity, you are burning society's resources. When in proof of stake, when you lock up capital, you're actually just redistributing society's resources because everyone else becomes slightly richer. And so, you know, it's not a waste of society's resources, which really bugs me. It's a public permissionless system. You know, I maintain that it is just you know, a lot of people will say, oh, there's more censorship concerns in proof of stake than in proof of work. You know, we can have this discussion afterwards, but I maintain it is just as censorship resistant as proof of work for any practical scenario. And so we can have that discussion later. Yeah.
So 2 questions.
Yeah.
First is around distribution.
Mhm.
So proof of work,
Mhm.
even though you may dislike the burning of resources, it is a very effective and fair distribution method to get
Mhm.
coins out into the market. And the second question is around how, like, what is the incentive for people to actually stake outside of, you know, like why would people lock up their capital? How is Cosmos going to people, you know, other reasons to allocate capital elsewhere? How do you
Yeah.
turn all those things?
I will answer that question in 2 slides. So, and then we solve this nothing at stake problem with slashing and unbonding period. So, Tendermint core, it tells the state machine, oh, I found these malicious validators, do what you want with them. And so our bonded proof of stake mechanism, it burns their coins and there's other things you can do with them. You could put them on a bulletin board and everyone can publicly shame them, but we focus on economic incentives of burning their coins. And we have a mechanism for delegation where the process of running a competent validator is not easy, as despite what a lot of Ethereum community would like to think. I run a validator called Sika, and it requires running a hyper secure, always online hotkey. And if anyone can hack that validator, they can burn all your money. And so that's not okay. And that's not accessible. Your grandma is not going to be running a validator, right? And so, but this delegation mechanism allows anyone who has coins to still, delegate it to a validator and still participate in the staking process, choose which validators to go to. They have skin in the game, so if their validator misbehaves, they get slashed as well. So they really have to be very careful with who they delegate their coins to. We have automatic reward distribution, so unlike for example, Tezos, a lot of their bakers have just been running away with their delegators' funds. Instead, we have an efficient mechanism for making sure the rewards get distributed properly to the delegators, and so there's no risk of the validators becoming malicious. The validators can't screw over the delegators without also screwing over themselves. That's kind of one of the goals there. And we also solve a lot of the stickiness issues with proof of stake, with features such as instant redelegation and something called validator commitments. I gave a talk at CSC. I'll have a link to that talk. You can go watch that if you want to learn more about proof of stake, about all of these cool features that we've created. And so to answer that question, the multi-token model, our claim is that we are not trying to make money here. The staking token should actually be only a staking token and nothing else. In fact, we make it very inflationary in order to punish someone who is not staking. Our goal is to have the majority of atoms be staked. We're talking about over 80% probably. Money in our system is going to be other stuff, maybe Bitcoin or stablecoins, whatever. And the incentive to stake is you earn the fees that other people are using. And so our system allows you to pay fees in any token. So you don't have to, like I said, we don't like these empires who are charging Ether for fees, right? We want a system where if you have Bitcoin and you want to pay your fees in Bitcoin, you can do that. If you have ETH and you want to pay your fees in ETH, you can do that. If you have DAI and you want to pay your fees in DAI, you can do that. So we have an entire mechanism designed to allow this. And so as a validator, your benefit of staking is that you earn the fees that people are paying in monetary assets like BTC and ETH and DAI and Dogecoin. And so it's very similar, and this staking token model is very similar to the ASIC security model, where it's why ASICs are more secure than GPU systems, because if you have the majority of staking tokens already staked, it's very hard for an attacker to suddenly buy up a large amount of staking tokens on the open market. And yeah, like I said, it massively improves the user experience, and we get away from this empire mindset where we have single fee tokens. Yeah.
You're saying, how come you don't think fees should be paid in the token that uses stake?
Because if the staking token has too much utility outside of staking, it's going to be too liquid on the open market, making it very easy for an attacker to suddenly buy up a large amount of the staking tokens. It's an argument with ASICs as well, right? You can imagine that almost every ASIC in every SHA-256 ASIC in existence right now is actively mining Bitcoin, right? Or Bitcoin Cash, I guess. But and that's why minority hash power chains are not secure, because it's very easy to suddenly bring in a whole bunch of new hash power into a chain that doesn't have it. But if you in Bitcoin, the ASICs are helping secure it, because it's almost impossible for any individual to go buy 51% of the ASICs in existence, right? And the only way for them to do it is to manufacture those ASICs, which isn't really feasible in in a non-detectable way.
You also mentioned this 80% is proof of stake.
That was a number I made up, but I'm talking about something like a high number.
High number, sure.
Yeah, yeah.
Is that a
No. Sorry, no. What I meant was 80% of the staking token. So let's say there's a billion atoms in existence. We want 800 million of them to be staked. That's what I meant by 80%. Maybe there's 200 million that's open because people are actively using them for trading or whatever they're doing with it, right? I don't know.
Well, I guess my question is, you guys are
Mhm.
token
Mhm.
you trade it, right?
Yeah, but the idea is it's going to be hyperinflationary. So if you don't, the longer you have your token not being actively staked, you're going to be getting like inflated away very quickly. In fact, we didn't want to do inflation. If we could have, we would have rather implemented it as a demurrage, where like if your stake token is not kind of like an ASIC, right? If you're not using your ASIC, it's just like degrading in value because it's not.
So my question is, how, I mean, for mining,
Mhm.
you set up in such a way it's a combination of proof of work and proof of stake.
It's only proof of stake. There's no proof of work at all in our one of the two, in this bonded proof of stake mechanism we're building.
Yeah.
There's no proof of work. Now, like I said, that's not to say you can't use proof of work in your own chain and connect it to Cosmos, right? You can completely do that. This is just one. This just has to do with that, like one of the goals that I really cared about, sustainability, and we wanted to build a tool that if your chain cares about this, use proof of stake. If you want to go use proof of work, you can do that, and it's completely permissionless. The point of Cosmos is to be an open system where it doesn't discriminate on this basis, on like the basis of that. Mhm. Yeah, and so and so basically what we've been spending a lot of time on is making sure that like our best to mimic the security properties of proof of work in proof of stake, and like especially like the centralization concerns. I think every proof of stake mechanism that's been proposed so far is going to be way too centralized until we've added these things like instant redelegation and whatnot.
So you're talking about losing to inflation.
Mhm.
You're also saying it's not inflationary. I'm trying to reconcile.
No, this Atom token is hyperinflationary.
Right. So
Beca-
does that mean
Mhm.
that new tokens are injected into the system?
Yes, and it's going to the staked
Okay.
holder. So if you're staked, it's going towards this. You get a cut of those new tokens. What I would have liked to do is do demurrage, where there's no inflation, but rather tokens that are not staked are just decaying in value. This would have been really nice. I think it's simplistically like it's mentally simpler to think about, and it would have also been nice from a tax perspective because then it's not income, but if you're staked, it's rather capital gains. That would have been nice, but it's just very hard to implement this from a technical standpoint and from a UX standpoint.
So you're basically saying people who have atoms stake, they keep getting more and more atoms.
Yeah, but really the
So
goal.
exchanges they're dropping in value.
Yes, that's the goal here, and the goal is to like allow. The idea is that people who aren't staked are having a smaller and smaller percentage of the total supply of atoms. And the total supply of atoms, the valuation can be like thought of as like a discounted cash flow on like future fees coming into the chain. Yeah.
How does that prevent centralization? Because it seems like if I have 30%
Mhm.
stake and it's hyperinflating, if it's not staked, because I'm getting all the new tokens, then the rich get richer kind of scenario.
Yes, but like like I said, it's not going to be that there's no liquid atoms, right? Like it's not possible to imagine that like 100% of atoms are staked, and we actually designed our inflationary mechanism so that the less atoms that are staked, the more hyperinflationary it becomes to encourage more to stake, and then as it reaches higher numbers like 80%, the inflation amount like decreases, so that way we still have some amount of liquidity in the open market. Yeah. Mhm.
So does the inflation come in the form of the transaction fee values changing over time? Or
No.
Are you, because you can in the market, in an open market
Yeah.
scenario, right? You can have any crooks you want,
Mhm.
but that's not follow that.
Um,
So how does that?
sorry. Are you saying does the inflation account for changes in price of
So
atoms?
You just inject more
Yeah.
coins, right? But the value of the transaction to stake, right, into something remains the same.
Yeah.
You just added
Mhm.
more currency to the system,
Right.
right?
We can't force rationality upon our users, but like the idea is that like in theory, as we inflate the system, each individual token should become less valuable, but the overall market cap of the entire atoms shouldn't be changing just because we're inflating it.
What are those ranges of inflation? Is it like
Mhm.
double in 7 years or like what's that?
Yeah. So no. So I'll say this, and I mentioned this in my actual proof of stake talk, which is this link right here. But like all of these constants that we're using are just made up right now. Like in my proof of stake talk, one of my constants I used like e over pi for one of my constants just to show the absurdity of of some of these constants, where these are, and they're just as absurd as like any of the constants that like even Bitcoin created, right? Like, oh, 21 million, where did that number come from? Halving every 2 years, where did that number come from, right? And so just proof of stake, I don't think we've seen any production implementations yet that are actually like solid and valid. And so hopefully as we deploy proof of stake blockchains, we'll slowly start to learn like where these constants should lie. And so for the Cosmos Hub, which is one of the chains we're building, we're setting the limit at the minimum inflation is 7% annual, and the maximum is 20% annually. Yeah. So if it's 0% of stake is staked, then the inflation percent is at 20%, and as 67, once it gets to 67%, it drops to 7%, and then it just remains constant for the rest at 7.
It said currency
Mhm.
is getting super value in the
Mhm.
future.
Mhm.
Does that mean that there's less at stake? You know what I mean? Just like from like a nothing at stake problem
Mhm.
perspective. Like if currency is too deflated, will people care if they lose those?
Yeah, because they have more tokens staked, right?
So it's the same like it's the
Same
value.
economic value of stake. Yeah, each individual token is less valuable, but the amount of tokens that are staked are increasing, right? Yeah. So if you want to learn more about this, so if you want to learn about all of these like features like instant redelegation, whatnot, watch this talk. If you want to read about this multi-token model thing, like I have like a a much longer form explanation justifying all of these things. This is a paper I just submitted for a conference. So don't like tweet about it yet because I don't want the conference people to get mad. But if you want to read it yourself, you can read it there. And then this is another paper that was talking about the efficient token distribution, reward distribution. Not sorry, that's a typo. It should be reward distribution. How do we make sure that validators don't run away with delegators' funds, but how do we do this in a computationally efficient manner? Without like iterating, because there might be millions of delegators. We can't iterate over every delegator, every block in order to give them their rewards, right? So we need to. This is just interesting from a computer science perspective of how we implemented this. All right, yeah. Any more questions? Final questions on this proof of stake? Yeah.
I hear about this game of stakes
Mhm.
that happen over time, like game of stakes 1 to whatever.
Yeah.
What is that? How is that directly tied into anything that you're doing?
Yeah.
What are you guys learning from those game of stakes?
Yeah. So in game of stakes, what we were doing was, it was a test net for our Cosmos Hub blockchain, and the idea there was I don't know. It was a weird idea. The idea was let's simulate a long period of time in a short period of time. So let's like make the inflation percentage instead of like 7 to 20%, we made it like 10,000% annually or something in order to like mimic like light speed over long periods of time. And we just wanted to see what kind of attacks happen in practice. And we were actually pretty happy because a lot of the cartel attacks and stuff just weren't able to happen because validators are actually competitive enough that they don't cartelize. And so that was very interesting that we just got. It was just a mechanism of, it did two things. Game of stakes, it helped like test some of these proof of stake mechanisms, and two, it just helped test our software.
Is that like the same thing as the Gaia networks?
So Gaia is the name of the software that the hub uses. And so yes, the Game of Stakes was a testnet running Gaia. Cosmos Hub is another chain that's running the Gaia code base. If that makes sense?
Yeah.
Cool. Yeah. I'll get into a bit of Game of Stakes later. Okay, cool. All right, next one. Next up, Cosmos SDK. So let's go back to our generations system. Generation 1, if you want to develop your own blockchain, gotta fork the Bitcoin code base. That's just a recap of what we're saying. Ugly spaghetti code, C++, very monolithic stack. So everything's in this like one code base, and there's like consensus logic mixed up with state machine logic and stuff. It's like, especially things like SegWit makes it even more like, and because of that, it's like, even if you fork your code base, you have full control over it, the sovereignty aspect, but you just don't have It's very difficult to work with. It's hard to make anything very advanced, which is why basically every early blockchain project was just a slight fork on Bitcoin, you know, changing the monetary mechanism or changing the hash algorithm. Nothing very fancy. Ethereum, you know, like I said, easy. Solidity makes it super easy, or super easy, but you know, easier. And you know, yeah, we already went over all this. It just makes it a lot easier. But you lose out on the sovereignty and all the stuff we talked about. So, Cosmos SDK. Here, the premise is let's build a framework for making it easy for people to write your own blockchains. And the idea is you're writing it in native code. It's in Go. You're compiling your blockchain code base and then running it as part of the client code. It's not running on this Turing complete VM. It's, you know, these application-specific blockchains, like, you know, smart. So this is what I was saying. Smart contracting is useful. And I'm a big fan of smart contracts, as long as that they're used as they sound, as a short-lived thing. Like smart contracts are great for that, but they're not great for dApps. You don't want to deploy DEXs, write DEXs in smart contracts. You don't want to write prediction markets in smart contracts. You don't want to write these complex systems. ICOs were the perfect use case for smart contracts. They're a short, one-time like use thing that's very short-lived. That was a perfect use case for smart contracts. But now we start people seeing like deploying like Augur on Ethereum, and it's just like it's not working. So most production apps don't actually need a Turing complete VM. You know the application logic, you write it in core code, and then you deploy it. Having these application-specific blockchains, it reduces the attack surface. Like, you know, you don't have to worry about the complexities of the VM, which essentially cause, like, you know, the DAO attack, both the parity bugs, etc. You get the efficiency gains due to lower computational overhead. So that, you know, EVM has, you know, about 100 opcodes. Let's say you just wanted to make a simple storage system, right? Nothing else. You don't need that many opcodes. You can, you know, you reduce the complexity. It's all compiled rather than interpreted. And you can fine tune to optimize for your application. So, you know, Bitcoin uses UTXOs because UTXOs are better for payment systems. They can be parallelized much more easily than the account model. But if you use the VM, you have to use what they tell you to use, which is like the account model. You lose out on that ability to fine tune, to optimize, and the customizability we were talking about. So the Cosmos SDK, it's a framework for building blockchain applications. You can think of it almost like the Ruby on Rails. Like the goal with the Cosmos SDK is to do what Ruby on Rails did for web development. It provided this very easy to use web framework that had a lot of packages or gems, and that, you know, you can combine into, like, you know, making more complex web apps. And so it's completely open source and available on GitHub. And it has this concept of, like, it's a very modular architecture. So, you know, you can pick and choose pieces from like these modules and fit them together to create your own blockchain. These modules are secured by, you know, this thing called principal. It uses principal of least authority using this thing called object capabilities, if anyone's familiar with those. But you know, it's fun security stuff. You can look into that. But yeah, and so the idea is, you know, you can use modules that other people have already built, or you can build your own modules and hopefully, like, open source them. Well, you have to open source them if you want to deploy your chain, but, like, you know, and downstream them to enrich and contribute to the Cosmos ecosystem. So, like, you know, we can see what I mean by this. You know, so we have these like core modules, which are, you know, we have accounts with coins and everything. We have that whole automatic reward distribution. Our entire bonded proof of stake mechanism that we proposed, we have it implemented in our staking module, slashing, IBC, I'll get into, governance, we have, like, you know, on-chain voting and everything. And so, you know, one of the chains that we're building is, you know, dog fooding our own software. And so, no, it more modules. Oh, also Tendermint is like you could think of it as a module in the SDK. Tendermint is cool because you can use it as both because it's in Go, you can use it as a socket protocol or with anything. But if you have your state machine in Go, you can actually import it as a library. So that's kind of cool. So you know, it's our core modules plus an extra module called Peggy. Aethermint is like, you know, the core modules plus this EVM module that we're writing. and this like shared security module. There's a project called Iris Network. They're doing some like microservices stuff that they're writing modules for. There's a project called Lino where they're like adding some like, an auctioning module, a bandwidth fees module. They have like a reputation module that they're building. Kava, they're a team that's like, writing a lot of payment channels modules and like some modules to interact with the Interledger protocol. Fourth State is a team based out of Blockchain Berkeley. So for example, they're using our PEGI module that we originally created for the Cosmos Hub, but they're like, because it's open source ecosystem, they're using that module along with their own Plasma module that they're developing. And so the idea is like, there's so many more modules that are yet to be built. This slide is actually a little bit old. We have some people already building like DEX modules and stablecoin modules and oracles and stuff. So there's a lot of cool stuff to be built and enrich this module ecosystem. And so the idea here is, the efficient state machine, all those benefits of application-specific blockchains instead of Turing complete VM. You get a lot of the customizability. So, the accounts module that we use actually does use account numbers, but you can also use the SDK to build a system that uses UTXOs. You have that full customizability there. You have it's easier to develop. Go is just way better than Solidity. It has like so much documentation around it, tooling, linters, IDEs, and a 10 billion. I don't know how much Google is worth. Like multi-billion-dollar company pouring billions of dollars of resources into developing this toolkit instead of having like 5 people at the Ethereum Foundation developing Solidity. And then it helps with the scalability aspect from the application-specific side that we talked about. And some more resources. So this SDK tutorial is this talk is part of a series. The third section, we're going to have to be doing going through this tutorial and building a sample module, a sample application on the SDK. So that's the link if you want to, get a head start or something. Here's the repo of the Cosmos SDK, and this is a blog post by Gautier, one of our coworkers. Just a longer form exposition on the case for why application-specific blockchains make sense. Cool. Any questions on the SDK? Cool. Oh, yeah.
How long before mainnet launches, do you think?
I'll get to that when I get to the Cosmos Hub section. Yeah. Yeah. And so the next 2 sections, 7 sessions of this series are going to be focusing a lot on the SDK. So the next one, Aditya from Fourth State is going to be coming and showing how he built a Plasma module on the SDK, and then the next one will be the tutorial. Then this is just sort of some of the other stuff that we work on, like more of the lower level lib stuff. We have like a protocol. We have a encoding standard called Amino. It's basically like what we claim is an improvement on protobuf. It makes it easier, like it's deterministic, which is nice. And then it naturally supports interfaces instead of using one-ofs like protobuf. And the cool thing with this is you can actually generate your proto files, your Amino spec files from Go code. So instead of having to write like protobuf files and then like having like the translator structs in Go and then like your actual operational structs in Go, you can just write your code and then Amino handles the creation of the tooling for it. It's just this nice developer tool. We do a lot of just hacking on side developer tools, and this is sort of like one of them. Another one is the IAVL plus tree. It's a self-balancing AVL tree where all the values are stored at the leaves, and it's immutable and so it updates using snapshots and caching. That's where the I comes from. And the plus is from the values stored at the leaves. All operations are log n, and no hashing keys is required. And so this is actually super important, which I don't think a lot of people realize, and I did not realize. For years, I have wondered why Bitcoin does not have a state tree. Why doesn't not make a Merkle tree of all the current, sort the current UTXO set and make a Merkle tree out of it? This would help a lot with proofs of non-inclusion. You can prove that a UTXO has been spent or has not been spent yet to a light client. This is so useful, and it makes payment channels much simpler and whatnot. And so I was always just so confused, and I've never seen a good explanation for why they don't do this. And one of the Bitcoin Cash devs, Amari Sachet, who I'll be doing an Epicenter episode with this week. So he's the first person who finally gave me a plausible explanation. Here's the reason. This is sort of like a tangent, but I just find it so cool. So I'm going to go on this. What happens is if you want to sort the Merkle, if you have a sorted tree, Bitcoin UTXO IDs are hashes as well, right? And so they're being inserted randomly into this tree. And because of this, every time you insert something into the key, you have to re-Merkleize it, and you have to get all the inner nodes and do all this re-Merkleization. If you as your state becomes bigger, you're going to stop being able to fit this in memory, and you're going to have to start writing this to disk, some of your inner nodes to disk. And now, because it's random, there's no caching strategy that you can use in order to kind of cache things, some of the inner nodes, and have some sort of predictable system. If there's no caching strategy and you're just constantly reading from disk, the system is just going to become so slow. Even Ethereum has the same problem. With their Patricia tree, they hash the keys and they write it to disk. And I claim that this is one of the biggest problems with Ethereum state model, and it doesn't allow it to scale. The TurboGeth team has been doing a lot of work to improve this, but I just think that when you explain this to me, I'm like, oh, that's so cool. I've never thought of this before. And so the cool thing is we don't hash our keys, so we don't have this problem. You can have an efficient caching strategy, and you don't have this state bloat causing an issue with disk reads and writes. Cool. And then we do a couple of other cryptography stuff. We have our own library with amino support built in, some cool multi-signature methods. Some of our interns have been working on from last summer, we're working on some BLS aggregate and multi-aggregate signature work, and some implementations and a verifier in the EVM. So this is just sort of other cool stuff that we just create open source work for. And we also have I'm not going to go into that. Yeah, so some of the the low-level libs, it just helps build stuff a lot easier, especially that cryptography library that has amino support. It makes it the development process makes it much easier, and the whole IAVL tree with no hashing, I think, adds to the scalability benefits as well. Yeah, and you can read more. Go Amino repo, IAVL repo, and the BLS repo. Does anyone have any questions about low-level libs? It's more of a small technical thing. All right, cool. So the SDK was a framework for building your state machine, right? You could write your state machine from scratch if you wanted to, and a lot of people do. I showed you, all the languages we have. People have already built stuff in. Most of them were just built using bare metal state machine code bases. But the SDK was meant to it provided you a nice framework, this modular system to make it easy to write a state machine in Go. But it's not going to be the only framework. And so we already have a internally developed secondary framework called Lotion.js. And so it's kind of probably hard to read from where you guys are, but it's super simple. It's this nice framework that allows you to write your state machine in JavaScript, and they're building their own little module ecosystem. It was created by two of our engineers, Judd and Matt, who recently just spun out and created a company called Nomic, still being funded by the ICF, by the Cosmos Foundation and whatnot. So this is really cool, and I think the use cases are different. If I'm going to be building a high security system, I'm still probably going to use Go, not JavaScript. But I think there are people out there who maybe will prefer the Lotion.js framework rather than the SDK. There's also one called IOV Weave. Weave is a fork of the Cosmos SDK. So one of our lead engineers, Ethan Fry, he used to work for Tendermint, and then he left about a year ago now. And so when he left, he actually took the version of the SDK he was working on and kind of forked it and kind of had his own little vision for it. He really wanted to make it much more simpler. Our SDK is very feature packed and has all these cool things. He wanted to do it as simple as possible with limiting a lot of the features. So I think it's a really cool framework as well. So there's that framework, and then over time, the idea is we can add more and more frameworks. So one of the things I really want to do is take Parity's building a framework called Substrate in Rust, and I think that would be really cool to we can just take any framework, put an ABCI wrapper on it, and have it run on Tendermint Core, and that's really cool. So that's something that I'm going to be looking into in the next few months of how to run use Substrate to also create Cosmos chains. And yeah, so benefits here. You get the whole efficient state machine, customizability, easier to develop. Here's the link to the Lotion.js repo, and here's the link to the IOV Weave repo. Cool. And Ethermint. This is a this is kind of a framework as well as it's a chain that we're building. Ethermint's kind of complex. So Ethermint, what we did was, if you remember from the previous slide, what I showed was we just took the EVM and ran it on Tendermint Core. We literally took Go Ethereum, Geth, stripped out their mining logic and just ran it directly on Tendermint Core. This is cool. We had Ethermint working and everything. But the problem is all of these staking modules and stuff that we've built, spent a lot of time implementing in the Cosmos SDK, we couldn't really use that in our Ethermint. We would have to rewrite our staking logic and figure out where to fit it into Geth. So instead, Ethermint 2.0 is we just created an EVM module inside the SDK. And so, it handles all the account databases, state trees, uses the same RLP encoding that the EVM uses. The cool thing, you can make calls from the EVM module into other SDK modules, and to the EVM, it just looks like a precompiled call. So, you can have a precompiled that's make a vote, and you can just call go, and it'll call the governance module in the SDK. So this is really cool. And so, you get the best of both worlds here if you are still using, let's say you already have a project that you spent a lot of time developing, and you already spent a lot of resources investing into Solidity code development. So you already have something. You get the scalability of Tendermint, you get all this modularity of the SDK, you get to use the existing ecosystem of Ethereum contracts and dev tooling, and you get the EVM module from TurboGeth. So we've been working with Alexei from TurboGeth to take a lot of his massive improvements he's done to the underlying state stuff and database performance improvements and whatnot. And so we're adding that. And the important thing is it is Web3 compatible. So there have been other previous implementations of EVM on Tendermint. The most famous one is by a company called Monax. It's a project called Hyperledger Burrow. So that is an implementation of the EVM on Tendermint Core. Problem is, it never did Web3 compatibility, and because of that, it just never really took off. But now that we have Web3 compatibility in this, it works with MetaMask and Truffle and all the tooling that exists right now. And so, if you want to use Ethermint, you really need that Web3 compatibility. Yeah, these are some of the improvements that Alexei has been working on TurboGeth. Not going to go into it. There's two ways to use the EVM module. You can use it as a blockchain on its own. So, you can just run a blockchain that has just the EVM module and some other core modules and just and you can just use it like you use Ethereum today. Or you can use it as a library where you can deploy your own Cosmos chain with EVM support. And so then you can this is useful because maybe you need some level of contracting capabilities for your users, right? But you want your core logic of your application to be in Go, but you want your users to be able to deploy some logic in Solidity. Or you also get you can use it as a modular upgrade path. So let's say you're a project like Augur, you've already spent a lot of time deploying your entire thing in Solidity. What you can do is you can launch it as a chain where currently all of your logic is in the EVM, but then over time you can start moving certain pieces out of the EVM into core SDK module and have it be this slower process of shifting over. So in Augur you can start moving your betting system out, then you can move your Oracle system out, and then you can move your marketplace for the rep tokens out or whatever. So it also provides an interesting upgrade pathway for existing Ethereum-based projects. Yeah, it's kind of a repeat of what I've said. And so, this really helps, especially on the, it helps the TurboGeth improvements help make the state machine way more efficient than Ethereum, mainnet Ethereum. You get that customizability because of the library and stuff. You can now you can add your own precompiles, and it's very easy to write precompiles by writing them as modules. And you get that whole one-click deploy that you already are familiar with Ethereum. And so this is a presentation that one of my coworkers, Chris, how am I doing on time, by the way? When does this end? Oh, okay, cool. Sorry. So this is a presentation one of my coworkers, Chris, gave. Yeah.
You've been talking to Augur and other Ethereum dApps
Mhm.
to basically tell them about the benefits of transitioning.
Mhm. Yeah, definitely. We've been, in touch with a lot of these projects, Augur, Gnosis, Maker,
What do they say?
most of them are definitely interested, and especially when pitching this low grade pathway, I think that's what got people very interested. I think for a lot of these major, that's kind of why we originally we were only thinking of Ethermint as a chain that we're deploying, right? Like Ethermint where you deploy stuff, and then we got Ethermint and then Cosmos SDK are separate, and but then we really wanted to help people push towards the SDK, but that really freaked people out. We're not going to go rewrite our entire stuff in that, and so now that we pitched this slower upgrade process, people seem to be pretty open to it, and a number of projects. I think Shapeshift is definitely one the Shapeshift. They have the whole. I forgot what it's called, that product of theirs, but some they're deploying on Ethermint and using the EVM, but slowly starting to write stuff in the SDK modules and stuff. Yeah, and then so a couple of people who are using. Oh, by the way, some people who are using the SDK, recently Binance announced that they're building their DEX using the Cosmos SDK, which is pretty cool. Yeah. So like I said, presentation from Chris at DevCon, kind of going through Ethermint and explaining that, and then here's a repo that you can take a look at. And now, finally, probably the thing that most people, yeah, sure.
Sorry, I had a quick question on Ethermint. So we've been following it pretty closely. It's a project we're working on, it's worked very well for us. But I saw that there hasn't been any development now for 2 months or so.
Yep.
I was curious, is this still part of y'all's plan?
Yes, sure. Yeah, so what's going on there is the Cosmos Hub was supposed to launch in December of 2017. We are now 14 months delayed. And so what we've kind of done in the past couple of months especially is all engineering resources are shifted towards focusing on the launch of the Cosmos Hub. But now that that's going to happen within next 2 or 3 weeks, we're going to shift resources back into Ethermint and other stuff. Yeah. Yep. Oh, right. Yeah. That too.
So, but if you want ERC20 functionality, do you deploy Ethermint or do you pick some other route?
So by ERC20 functionality, it depends on what you mean by that. If you're talking about you literally want ERC20s, then yes, you need to deploy an EVM module. If you want a custom token, the SDK provides a mechanism for you to have tokens, and you can have as many tokens as you want in the chain, and each token is native. The ERC standard of doing tokens is very bad. As a contract, it's not it does what in our system in the SDK. It allows you to have unlimited native tokens, and so that allows all these tokens, like I said, to be used to pay for fees and whatnot.
What's the development process? Because let's say with Ethereum, you just inherit from an ERC20 token, flatten it out, compile it to bytecode, deploy it, and you're done, right? How do you do that?
So keep in mind here, we're talking about application-specific blockchain. So the idea is whatever token you need, you should have deployed it when you deployed your blockchain, right? But you're not going to add a new token on later. Does that make sense? But you can have mechanisms that modules that allow people to mint tokens. So I can have a module called Minter, and what I can do is any user can just send a transaction saying, hey, make a new native token called Sunny token, right? And it will do that, and it'll create it as a native token and everything.
So the thing to research is the Minter module.
Yeah.
And how to create tokens with the Minter module. And there's some sort of a spec with a transfer and balance of that. Do you have a template to start off?
We're,
figure that out yourself?
we're working on that. There's a sample minter module in the demo coin example in the SDK repo, but like I said, that is definitely needs a lot of work. We've kind of built all these sample modules we used to be building, kind of all on pause right now, waiting, like focus on hub launch. Another cool sample module that's on there is this proof of work module, where what it does is like you. So I'm personally of the belief that proof of stake is better for consensus, but proof of work is better for coin distribution. Like everything that you were saying about, like, I think proof of stake is too centralizing for monetary distribution. If you wanted to try to take your shot at like making money, I would say still use proof of work, but you can. So we have a module that like people can submit these hashes and it mints coins for those hashes. And so you can write modules that like emit coins and things like this.
So with Open, you probably know Open Zeppelin, right?
Mhm,
This is a repository where you have dozens of contracts that you could look at. For example, like you want an escrow, here's how you build an escrow.
Yep.
In ERC20 token, here's various
Yeah.
versions of that with minting and rolls and all that. And I'm wondering if the
Yeah,
modules are the parallel
Yes.
of that.
Exactly. That's what the modules are the parallel of. Although the one thing that's missing, I'm sorry, the one thing that's missing right now is we don't have the like common repository yet. Like, so the nice thing with like Open Zeppelin is all in this one GitHub repo. It's very nicely organized, right? Right now, that the modules are supposed to be exactly that. It's the equivalent of that, but we need some mechanism of like organizing them and like maybe some website where developers can like upload their modules, and then there's also this question of auditing. Like, we need some mechanism for like people to read these modules and basically like maybe assign some stake to it and basically say like, oh, I'm staking my reputation because I audited this module. And
conceptually, is that going to be modules are going to be Go code?
Yes.
You pull down, compile, and then redeploy to Cosmos?
To your own chain, yeah.
Okay, so it has to be to your own chain as
Yes.
opposed to a public
Yes, yeah.
chain like Ethereum or
Yeah, yeah.
or EOS, for instance.
Exactly,
And,
yes.
And then that is it's two different approaches to deployment, basically.
Exactly.
Right? So you're never going to deploy to a public chain.
No.
With Cosmos.
No.
Or with Ethermint.
No. Yeah. Or you can upgrade the public chain through governance or some whatever mechanism, right? You can say that like governance can choose to add modules, but that's like hard fork upgrades, right? Not hard fork. It doesn't have to be hard fork, but those are upgrade processes. It's very different than. It's not like Ethereum where you're uploading code and running it. It's like it's application-specific blockchains. You know your application and you're writing that code and you're deploying the application, not like
So just another quick question. So I guess another concept that I think about is when you're dealing with a public blockchain like ERC20, if your company ever goes away, hypothetically, somebody else may step in and kind of make use of the existing tokens that are out there floating that people have private keys to. Does that concept not apply to anything?
No, it applies completely here as well. It's like it's the same. It works the same way here. Like, think of it similar to like some of the early, like the generation 1 blockchains. Like, just because they're application specific doesn't mean they're not public chains, right? Like, for example, let's say Namecoin, right? Namecoin was originally developed by like what's now the Blockstack engineering team, right? But that team stopped working on Namecoin and instead started working on Blockstack, right? But Namecoin never died because it's this public project that like other developers took over and like continued developing it. Just because something is application specific does not mean that it's controlled by one company or it's not a public system.
I guess what I imagine is when you have a whole bunch of validators that have their own private keys, and one company controls that if that
it doesn't. But those validators don't have to be run by 1 hours, right? You can actually just like send the most recent block as long as the validator set did not change by more than 1/3. And even if it did, there's a efficient like bisection algorithm that we use to like how you can transmit the fewest number of blocks necessary. And in a proof of work sidechain, on the other hand, let's say there were like thousands of blocks that went by. The next time you transfer a packet, you have to send every single one of those thousands of blocks, and that's just not very scalable for like you can imagine why. And then the light client is also nice, like just even minus like the for the IBC, it's just really nice from like a user perspective. Like, you know, if you turn your phone off for the night, and you turn it on in the morning, there's probably about, I don't know, like 50 or so Bitcoin blocks that went through it in that time. I've checked my phone can do about like 3 or 4 SHA-256 hashes per second. So it'll still take me about 10 seconds to like sync up to the chain. And that's Bitcoin, who has 10-minute blocks, and SHA-256 a very easy hashing algorithm. Like, I've never actually tested it with Ethereum because there are no blocks, very complex hash algorithm. It'll probably take me like a few minutes just to sync my light client up to the head of the chain on my phone, which is all for one night. And you know, Tendermint just, you know, it makes it way faster. You just jump the blocks and then you do a couple of signature checks, and these signature checks get more efficient once we do the BLS aggregation I was talking about earlier. So essentially, what's happening here is you are basically, you know, 2 chains are light clients of each other, and you send this packet between them, and it proves state. So you know, something happens in chain foo, and you kind of like it, and it's logged in the state somewhere. You send a message. You make this packet format out of it, and a message relayer, which is some node that will be incentivized some way, which is still one of our main focuses of research right now, how to do this incentivization. But they'll go ahead and transfer it, relay that packet to chain bar, and chain bar will have some mechanism of like, you know, acting upon that, and then it will send a like confirms message back to chain foo, and then chain foo can act on that return message however it wants, maybe like, you know, deleting that log event from its state so it doesn't just fill up its state with like thousands of log events. And so, you know, this is equivalent to like application. And so, you know, it's the IBC itself is similar to like the TCP IP stack, but on top of this, you need, just like in the internet model, you need the application layer. And so, just like in the internet, you have like application protocols like HTTP for web, or you know, SMTP for email, FTP. You have all these FTP. You have all these different like protocols on top, and so you're going to need to do the same thing for IBC. We're going to have to design these higher level protocols. So the one that we're starting with now is just simple token transfers, because we think that handles the majority of the value. And so how that works is, you know, what you do is you lock up coins here, you send a packet moved. B gets that packet, and you know, you unlock the coins. And what you can do later, if you want to go in the other direction, which I don't have the animation for, unfortunately, is you burn these coins, and then you send a packet to chain A, saying, here's some proof that I actually did burn these coins. And then chain A will say, okay, cool, I'll remove the lock on these coins for you, and you get the coins back. And so really what these tokens are here is they're a claim to the locked asset on this chain. And so that's essentially acts as token transfer. Yeah.
So if I want to spend on those coins for something,
Mhm.
it would then go back, but I have to like send a packet back to A.
No.
Hey, like, you
Mhm,
can
mhm.
use the lock coin.
No. So, well, if you want to send, let's say you want to send it to someone on B, right? You can just send the asset directly, because the asset it's a bearer asset on the claim to the underlying locked asset. So I could send. So I locked these coins. I got them here. I can send them to you, and then you can be the one to burn them here, and then these will get sent to your account here. So when you burn them, you tell this protocol which account to send the locked coins to. So, you know, you can use that for token transfers, which is what we're focusing on now. You could use it for non-fungible assets, or NFTs, as like people like to call them. You can use it for data, like oracles. So, like, you know, you just have like some data, prove to me that something happened on this other chain. I think like private chains can serve as very valuable oracles for public chains using this method. And then there's this thing called agoric ERTP,